India gathered at the prestigious event of Next Gen High-Rise Building Advancement in Composite and Steel Structures Conference organized by the Association of Consulting Engineers in association with Instruct. This event represents a collective platform of exchange knowledge and share experiences and explore the advancements that are shaping the future of our profession. I want to extend warm welcome to each one of you and as we embark on a discussion and promise to enrich our understanding to foster the innovations of high-rise structures. Let me take you on a brief journey through the time. Imagine the moment towering pyramids of Egypt, constructed nearly 45 years ago, and some temples in Dwarka even earlier. These architectural marvels stand as a testament of the ingenuity, determination of the early civilization. With no modern equipment, advanced materials, they mastered the art of building enduring the structures, relying on clever geometry, human labor, and deep understanding of the environment. Fast forward to the Roman Empire, where we witnessed the first major use of arches and lime concrete. The construction of the Colosseum and the aqueducts revolutionized how the large structure introducing the elements of durability and functionality that was previously unimaginable. Now, mid-19th century, reinforced concrete got developed. This was an era when the modern structural engineering truly came on its own. The introduction of steel and advancement in the construction techniques led to the creation of some of the world's most iconic structures, such as Eiffel Tower and the Brooklyn Bridge. It was during this time the civil engineering evolved into being the craft into the science driven by the principles of mathematics, physics, and material science. As we construct the high-rise buildings, they pierce the clouds, bridges that stretch unimaginable, impossible distances, structures that can withstand the wrath of nature. Modern civil engineering is a culmination of centuries of experience, innovation, and hard-earned lessons. It is ever-evolving field, continuously adopting the new challenges such as urbanization, sustainability, and climate resilience. But despite of all these advancements, one fundamental principle remains unchanged. Every structure, no matter how grand or complex, relies on a solid foundation. The foundation where it all begins, where the dreams meet the ground. Without strong and stable base, most advanced designs are nothing but castles in the air. Introduction to the grillage foundation. This brings the focus of my topic today, grillage foundations. While the foundations might not always capture the public's imagination, same way the building's facade or height might, they perhaps are most critical, ensuring the stability and the safety. As among the various types of foundations we use, grillage foundation is particularly fascinating for its versatility, effectiveness, and addressing the soil conditions. My experience tells me that not many people want to use a grillage foundation though, because they find that it's more costlier, but somehow that's not really the case. Anyway, grillage foundations are essentially a framework of beams, what you see in the slide, arranged in tiers and encased in a concrete. Of course, you can leave them even not encased also. We just fill it with the soil. But then you have to worry about the corrosion effect, if at all, if there, and then you can add the thicknesses to that. The design not only ensures the building remains stable, but optimizes the use of materials, making it economical, practical use for the certain applications. Especially grillage foundation works is according to me very reliable, especially for industrial structures where they are going to use the long span structures are there, and where the alignment of a structure is very important. As well as even in the high-rise structures, that is also the case of the foundation, because it's very important and the space is constrained. In an age where the cities are vertically expanding and construction sites are located in the areas with poor soil conditions, grillage foundations offers an elegant solution to the complex problems. They are commonly used for the industrial structures, steel columns, transmission towers, and even temporary equipment bases. The beauty of this type lies in its adaptability. It can be made from steel, timber, reinforced concrete, depending on the specific requirement of it. The details of grillage foundation, including design, components, construction process advantages and locations are what we should think of. Together, we explore this type of foundation continues to play the vital role in the modern construction and how it helps to overcome some of the most pressing challenges in the civil engineering. As we delve into the intricacies of grillage foundations, I encourage you to think beyond the technical as well as codal details and consider the broader significance of what we do as a civil engineers. We are not just building the structures, we are building the future. These decisions will make every design we create, every innovation we embrace has a potential impact on the countless lives. Grillage foundation, you see, just seems to be one small piece of puzzle, but essential one. It represents the ability to adapt, innovate, and solve problems even in the face of challenging conditions. By understanding and mastering the technique of these, we equip ourselves to meet the modern demands. The only thing what we do even in the marine structures, we have used this grillage foundations wherein we have added the thicknesses, especially to the web and sometimes even in the flanges. And the structures are standing there for 30, 40 years without any problems.